Hello, we're going to discuss the CPU and how does it work. This is a basic overview of the internals of a CPU, or control processor unit. The program counter is a specialty register. It always contains the address of the next instruction that will be executed. L1 is a very fast memory on the CPU. Every instruction has to be taken from memory. The CPU can execute instructions much faster than they can be fetched. The instruction register contains the instruction that is currently being executed. Its bit pattern determines what the control unit is causing the CPU to do. Once that action's been completed, the bit pattern in the instruction register can change, and the CPU will perform the next operation. The control unit is what controls the activities of all the units in the CPU. Register is the main group of several bytes of memory within the CPU. Almost all arithmetic and logic operations and data movement operations involve at least one register. The arithmetic logic unit performs arithmetic and logic operations on groups of bits. The bus interface is a means for the CPU to communicate with the rest of the computer system. It contains circuitry to place addresses on the address bus, read and write data on the data bus, and read and write signals on the control bus. Condition flags are bits in a status register that show results of many operations performed by the arithmetic logic unit. For example, addition can set the carry flag to show whether or not carry was produced.
So today we're going to talk about CPU and the interaction with memory, and I have this picture to help us do so when I start explaining like an example and so forth. So let's say we try to store some data in the memory. So let's say we have some data in one of the CPU registers. So to store this data in the memory, the state of the group of bits in the memory has to match those in the CPU register, and then the control unit can be programmed to do this, and then with these steps. So first, we have to place the memory address on the address bus. And then from there, we have to place a copy of the register bit states on the data bus. And then we have to place a write signal on the control bus. So let's just use an example with 8 bits on the memory. And then we have this address of, this combination of these letters and numbers. And then it's at B7. So in this state, from there, the R0 register state in the CPU is so and so, like letters, numbers, and then at the end, let's say it's at CD. So the control unit is programmed to store 1 byte from that register state at R0, with the CD. So the control unit is then going to place that first memory address that we got from the 8 bits on the address bus, and then from there we're going to place our second state or register in the CPU on the data bus. And then from there, we're going to place a write signal on that control bus. And this is going to change the memory location from the first memory address with the B7. And it's going to change it to, the same exact, data and address. But instead, it's going to be at CD. And also, when we do this change, once it's stored and everything, we can't undo it or know how it got there. So just be careful when storing data, because there's no undoing of the state, when in the register and in the bit state. So this can be undone, and there's no possible way to do so. So that's one way to explain CPU and interaction with memory.
What's up, guys? So I will be discussing the fetch, decode, execute cycle. Basically, the CPU will start by fetching an instruction. It will decode that instruction, proceed to read the address from memory, and finally execute that instruction. And it will repeat this cycle billions of times every second. So here we have a diagram of the CPU with some of its components in the RAM. So first, we have a program counter that will point towards the memory location. Then the address register will fetch whatever memory location that may be and store it inside it. And the data register will fetch whatever data is inside that memory location. And finally, the current instruction register will just store whatever address was in the address register. Once this is all said and done, the program counter will increment towards the next memory location that needs to be fetched. So once the current instruction register has a memory location in it or an instruction, it will send that instruction to the control unit. The control unit will decode it and will execute whatever instruction was sent to it. So let's say it was asked to load whatever was in this memory location right here, then the address register would pull out this memory location, store it inside of it, and then the data register would pull any data or information that was stored in there and send it to the accumulators stored inside the arithmetic logic unit. And the CPU pretty much repeats this cycle over and over again. And that's how the program would be executed in a rather simple computer.